Hi, today we're going to talk about weather. We're going to talk a little bit about how it forms, how air masses work, and a little bit about precipitation. So first, let's talk about precipitation. Precipitation occurs when clouds have water vapor in them that condenses into bigger and bigger droplets of water. When the drops are big enough, they fall to earth as precipitation. It can be in four forms: rain, sleet, snow, and hail. Let's talk about rain first. Rain is precipitation that falls to earth as liquid water. The droplets, have a diameter of at least 0.5 millimeters. Most rain originates from nimbostratus or cumulonimbus clouds. Heavy rainfall is known as a cloudburst. Next, there's snow. It is precipitation in the form of ice crystals. Their size, shape, and concentration depend on the temperature in which they form. At lower temperatures, the moisture content in the air is small, so the snow from conditions like these with these lower temperatures form the powder snow that skiers like. So it's the more powdery snow from the colder, drier air. Sleet is formed when a layer of air with temperatures above freezing lies above a sub-freezing layer near the ground. When the drops leave the cloud, they start out as water and the warmer air, and when they encounter the colder air below, they freeze before they reach the ground, and it's in the form of sleet. Hail is in the form of hard pellets of lumps of ice. It is produced only in large cumulonimbus clouds, and updrafts in these clouds can reach 100 miles an hour. And there's also a supply of super cold air needed to form the hail. The hail starts out as small pellets of ice that they get caught in the updraft in the storm. This can carry them up and down within that updraft, and each time they make this trip up and down through the cloud, they grow larger in size by adding ice layers. They finally fall to earth when they enter a downdraft, and then they fall to earth as these hard pellets of ice. And it's usually, within a severe thunderstorm, and we get a lot of that here in Oklahoma. So I'm sure everybody's familiar with hail. It can cause a lot of damage if it's big enough, especially. All right, now we're going to talk about air masses. Air masses are immense bodies of air, usually 1,000 miles or more across. They are characterized by a similarity of temperature and moisture at any given altitude. And even when the air mass moves out of its region, it's going to take its temperature and moisture conditions with it. Air masses are commonly classified according to four basic source regions, and that's with respect to altitude. They are polar, which would be cold, Arctic, which would be very cold, equatorial, which would be warm and moist, and tropical, which would be warm. Oklahoma is in what is known as Tornado Alley. Since we all live in Oklahoma, we're familiar with that. Oklahoma has traditionally gotten a lot of tornadoes, and this is due in part to its location. It gets warm air coming in from the south, off of the Gulf and coming up from the Gulf of Mexico, and then it's getting cold air masses coming in from the Rocky Mountains. And the tornadoes form when these two air masses collide, and the denser, colder air mass coming from the Rockies is pushed up over the warmer one. This produces thunderstorms, and the warm air rising through the cloud causes updrafts, and these updrafts in form cause the tornadoes. We're going to talk a little bit more about the air, how it lifts. Lifting air is required to form clouds and precipitation, so that's kind of the basis of where weather begins. Two types of lifting are convection and orographic. Convection refers to air rising vertically in the atmosphere due to heating. And we've got a little diagram here of what convection convergence lifting looks like. You can see it there in the diagram. Next we have orographic lifting. This is when air cannot go over a mountain, through a mountain, and so it flows over the mountain. Frontal lifting is when less dense warm air is forced to rise over cooler, denser air as the weather front moves. So you can see a picture here of what orographic lifting looks like. The air mass encounters the mountain. It can't go through it, so it's going to go up over the top of it, and that air comes down the other side as dry air. It comes up as moist air, and then after it gets over the other side, it becomes dry air. So that's how orographic lifting works.